All right, this is lesson 6.3, similar triangles. The goal for this lesson is I can identify similar triangles using AA, SSS, and SAS theorems. Well, AA just stands for angle, angle. And then S's stand for sides, so this would be side, 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 and this would be side, angle, side. So there's three methods that we can prove or identify similar triangles, okay? So the first one is simply called angle, angle. And it simply says if two angles of one triangle are congruent to two angles of another triangle, then that's all it takes for them to be similar. Okay, so I could just draw a pair of triangles out here like this. That's horrible. That was absolutely awful. There we go, and then I can draw like a littler one. And as long as I knew this angle was congruent to that angle, and maybe this angle is congruent to that angle, I could say that they are similar. That's all it requires. So, example 1, determine if the two triangles are similar. If so, write a similarity statement. Okay, so I don't have all the measurements of all the angles here, so I probably need to spend some time finding those. So in this first triangle, I'm going to add 48 and 57 together. 15 carry 1, that's 105. So that means the other angle would be 75 degrees. When I look at that, I've got a 57 here and here. I got a 75 here and here. So I know that angle L is congruent to angle M, and angle K is congruent to angle P, and therefore I have angle, angle similarity. Okay, that's the reason, is angle, angle. So I know they're similar. So now I'm going to write triangle, and then let's just pick any order for this first triangle. It doesn't matter what order you put the first one in. So I'm going to go with LKJ is similar to, and now it matters, I'm going to match up. L went with M, K goes with P, and that means that J must go with Q. And there's my similarity statement. Okay? So you try. All right, hopefully you looked at these triangles and you're like, where are the angle measures? Well, this one doesn't have any, but there's some information given to you, things you need to start looking for. You see this pair of red triangles on those two lines means that they're parallel, so we've got this pair of alternate interior angles here with the capital Z's and capital N's that we talked about. So here's this capital N, and the knees of the N are congruent, and then you could say here's a pair of vertical angles. They're congruent. And so now I suddenly know that angle R is congruent to angle W, and I know angle RSX is congruent to angle WST, and that's angle, angle. So these are similar. So I'll go with RSX, similar to, I think I used, yeah, I did similar, didn't I? Triangle R. R goes with W. S goes with itself, because they're a vertical angle pair, and then that leaves me with T to go with X. All right, so that's angle, angle. Try this one. Hopefully you took 90 and subtracted 44, because this angle is 90 already. And that's going to be 46. Well, I don't have anything matching the 47, so these are not similar. Got a 44 and a 46, and that's a 47. Well, there's no congruency there. So we got the right angles congruent, but nothing else. So that's not enough. All right? Try this one. Again, it's about you seeing the information that is given to you on the drawing. Again, parallel lines. When cut by a transversal, this time I've got corresponding angles congruent there, and another pair of corresponding angles there. And they both share angle L. Angle L is the same angle in both triangles. So we definitely have, angle let's go big triangle first. So angle K congruent to angle Q. We got angle J congruent to angle P. Then angle L is congruent to angle L. So we definitely have angle here. So the statement is JKL similar to J goes with P, K matches Q, and L matches L. All right, here's two other methods. This one's called side, side, side. And so in this case, it's not whether they're congruent, but just like when we were doing similar figures before, they have to be proportional. So the ratios of the sides have to be the same for all three pairs of sides. Then you've got a similar pair of triangles. Or you can have two pairs of sides, and then notice the angle is between the sides. That's called the included angle. That's going to be between two sides. That's what it means for the included angle. The included one's between the sides that you've got here, your two S's. And then you can use side angle side to prove that they're similar. So let's look at this one here. It's always a tip-off when all the sides are labeled. Guess what you're going to use if all the sides are labeled? Well, you might find an angle pair that's congruent, but let's use all the sides on this one. So what I have to do is I have to set up three ratios. And I'm going to put this top triangle on top and the bottom triangle's numbers on the bottom. And I'm just going to go small, medium, large, because that must be how they match up. The small on the top triangle has to go with the small on the bottom. So we're going to go 5, 6, 8 across the top, and then match up the lower ones. So we've got 12.5 is the smallest, 15's in the middle, and 20 is the large. So cross multiply, 5 times 15 is 75. So this way I get 75. And this way I get 6 times 12 and a half. I think that's 75 also. Yeah, it is. So that pair checks out. Now do the next pair. 15 times 8. That's 120. And 6 times 20 is also 120. And so that pair checks out. So these triangles are similar by side, side, side. Okay? Now we got to write the statement. PQR. I just chose alphabetical order up top. So what angle in this lower triangle does P match up with? Well, if you notice, it's between the middle and highest pair. So P is formed by the middle value and the highest value. And so here are the middle and the highest value on the lower triangle, and that's angle S. Well, then I know for vertical angles, both the R's have to match each other. So Q has to match with T, and then R goes with R. And the reason here was side, side, side similarity. Here, you give one a try. All right, the thing here you need to notice is angle A is an angle in the small and the big triangle. So that's a pair of angles. That's of the side angle side. At least I know the A part. But they did give me some side lengths. So I'm going to do just 2 fractions because I'm only comparing 2 pairs of sides instead of 3 on the previous one. This was side, 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 so I needed 3 ratios. For side, side, side angle side, I only need 2 ratios. So for the upper triangle, I'm going to put 8 on top, or 8 and then 10, because that's small, large. But now notice you've got to use the entire lengths of the bigger triangle. You can't just use 4 and 5. 8 plus 4 is 12, and then 10 plus 5 is 15. And so I'm going to put 12 on bottom here and 15 on bottom of that, and that's small, large. And so 8 times 15, that gives me 120, and 12 times 10 gives me 120, and this checks out. So these triangles are similar. So I'm going to go with A, E, F, similar to, well, A goes to A, E matches with C, and F matches with B. And this is by side, angle, side similarity. Okay, give 5 a try. So we can just start talking about some things to kind of narrow down when do I know what to use, right? Well, this one's easy. 3 sides, no angles. Oh, that's what you're going to be given. 3 sides, no angles. Well, that's not what we have. Here we have 2 sides, but no angle. Well, that's your tip. That if you have 2 pairs of sides, there's probably look for an angle, right? Look for an angle. So like the vertical angles here. And it's got to be the angles between the sides. So 22 and 20 form that angle. So that's why it's called the included angle. And then 10 and 11 form this angle. So that's why that's the included angle. So then you just need 2 ratios here because you've got the angle part. Now we need the sides. So look at the left-hand triangle and go small, large. There we go. Look at the right-hand triangle and go small, large. And 10 times 22 is 220, and 11 times 20 is also 220. So yes, these are proportional. So I can write my similarity statement. I'm going to say W, T, Z, similar to. Now, you just don't have to, as long as your letters correspond correctly, there are lots of ways to name these triangles. So don't think that this is the only way you can write the similarity statement, okay? So I say WTZ, and then W matches with W, that's the vertical pair. But should I go to Y or X? Well, here's how you know. From W to T, I went down the shorter side. So from W, I've got to go down the shorter side to Y, and then X, okay? And this was by side, angle, side similarity, okay? What are you going to use? It's 3 pairs of sides. The only thing I can use, side, side, side. So 8, 12, 16, 6, 9, 12. Well, 6 times 12 is 72, and 8 times 9 is 72. 9 times 16 is 144, and 12 times 12 is 144. Well, these check out. Okay? So I've got side, side, side. I'm going to call my first triangle JKL, similar to J. What's J between? J is formed by the medium and the large. So here's the medium and the large. They're forming Q. K was formed by the large and the small. So 12 and 6, so P. And then we need M. Okay? This is by side, side, side similarity. All right, example 3. This is the way they're going to look in IXL. So which rule explains why these triangles are similar? So you can see side, 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 angle, angle, or they're not similar. Okay? Well, what have you been given in this drawing? Have you been given any angles? Well, that's always my first question. Well, these 2 triangles do share angle T. So then I've got to use the fact that they've labeled sides for me to, to figure out if these 2 triangles are similar or not. So I have to use these 2 sides that form angle T. So I need to use the 12 and the whatever that is, and the 10 and the whatever that is. So 2 ratios, because I've got 2 pairs of sides I'm checking. And I'm going to put 10 and 12 on top. That's from the small triangle, this one right here. This is my small triangle. And then from the large triangle, I need to add these sides together. 6 and 12 make 18. 10 and 2 make 12. So then 12 and 18 go there. Well, this makes 180, and this makes 144. So my answer to this is they're not similar. Okay? All right. You guys try that one. Okay. hopefully you just did a little work here, and 50 plus 30 is 80, and 180 minus 80 is 100. So that's 100 and that's 100. Well, I don't have two matching pair. Here's one pair that match, but the 54 doesn't match either one of those. So again, these are not similar. I don't have any sides, so my only hope was angle, right? No side lengths, so I can't use those if I don't have any sides. Okay, so you look at IXL M8 and see how you do on that one.